Hello everyone and welcome back. So it is time for us to begin the construction of the final digital asset that we're going to be using in our Talented Ball project. We call this digital asset the bleachers, but that name is just a bit misleading. Really, what the bleachers consists of is the stadium, the bleachers that sit on each row within the stadium, and finally, our crowd. We talked about breaking the crowd apart and having the bleachers and the stadium as one asset and then creating the crowd and then bringing it together. But you're going to see as we work our way through the construction of this digital asset that all of the parts really all work together. Big time. Wouldn't you say?
They're very intertwined in the way that they're constructed because, well, you'll see in the videos, but the constructions and the way they're laid out is very similar. So it makes sense to build them together.
That's right.
And so we're going to build them together in one single asset.
What's the purpose of a digital asset? To provide a portable tool, if you will, or some sort of portable asset that an artist can simply take to another computer and employ in a project. Let's think about this for a second. Having the stadium with the bleachers as an asset makes a lot of sense. Having a bunch of floating spheres that have animation and all that are going to be positioned on that bleacher and stadium, but just floating there by themselves, that doesn't make a lot of sense. I mean, if we had the ability to say, turn our crowd off, well, then that's fine. The one asset would still make sense. But to have these two entities separated such that the crowd was off by its own, I just don't see where we would ever use that. Because you would see the spheres floating in space as they were sitting on each invisible set of rows.
And they're positioned specifically for the bleachers that we've already created.
That's right.
And so you wouldn't easily be able to create another stadium that they'd sit on.
Yeah, exactly. So what we've decided to do is to create this as one system. So this is our crowd system, which would work great for any sort of scene that you're putting together that requires some sort of rounded-like, I don't want to use the word rounded. What's a better word? Cylindrical-like stadium.
Yeah.
Will that work for you?
That works for me.
It's still rounded. It's you guys are going to see when we're laughing about this. It's rounded, but it's not rounded. All of our columns are very straight edge.
It's a regular polygon, really. And,
there you go.
Yeah,
I like that.
That's the maths.
But if you need a crowd that's sitting on bleachers in a rounded stadium, this will work perfect for whatever kind of scene you're putting together. In our case, it just happens to be our Talented Ball performing for our crowd. So that is what's going to be created. And again, a bit misleading with the name. We're just going to call this bleacher. So go ahead and accept that now. Now, what I'd like to do is point out how we're going to do these videos. Up until now, we've had a very small number of videos used in the creation of each of our assets. But the bleachers, it's a bit more involved as we work our way all the way up to the end, which consists of some very powerful custom shaders, a very powerful crowd simulation system, a bunch of maths. There's a lot of stuff going on in this asset. And what Steve and I have decided to do is instead of presenting some relatively large videos in constructing this, we've decided to keep the videos very small so that each item that we're working on is highly focused and everybody can keep the objective of that video in mind from start to finish without losing sight of where they are. So I just wanted to point that out real quick. Now let's go ahead and jump over to the whiteboard and let's spend a few minutes over here. First of all, what exactly are these bleachers going to look like? Well, let me begin first with kind of a profile. So they're going to look like, well, first let's just start out with the stadium. So here we are with the stadium. This is one row, so I'm going to call it. And I'm going to give you a complete side profile. So we've got this tube sticking up, and here's a seat, which is the bleacher. A long bench, basically, with two tubes that mount down to the stadium floor. And the stadium floor in this particular case is this guy right here that we're sitting on. And then on this guy, we have a series of balls. Now, of course, the guys are looking out to this in front of them, so this is a side profile. Now let's come in here and say, what if we had 2 rows? Just so that everybody gets the terminology that we're going to be using down. So here's 2 rows. Another side view of a bleacher or a bench and another sphere sitting on it. And let's go ahead and draw one more. And once again, here's a bench that doesn't have anybody on it. Now, that gives us 3 rows. Now, obviously, we're going to set the asset up such that we can have anywhere from 1 to 100 rows or 1,000 rows. It depends on what the artist needs. That'll be fully controllable. Now, this needs to have a side, and this side is going to end up making the thickness of the stadium all the way around. And that's not as straight as I want it to be. Let me straighten that up a little bit. So for our first 2 rows, it's always going to be a straight line that's going to go up underneath it as I continue to battle with being picky. And from there, it's going to go up, over, and in here we'll close the back. But for each row that goes up after this, you're going to see this in the back as well. And that will simply just match with this guy, like such. Let me undo that. And with each of these underbellies of the stadium, we're going to end up with tubes that come down into the ground that provide stable support for the stadium as it continues working its way up. So again, if we end up in a situation, this is the underbelly, we'll have tube, 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 all of the tubes coming down to the ground. Okay? Let's go ahead and erase that out real quick. All right, so here we are. This is a very nice looking profile. So what does this look like from the top? So here's a top view. We've got, basically, let's start out with the stadium is as we said, and we're kind of laughing about earlier, it's rounded like.
Yeah.
So it's going to be a 180-degree sweep, like such. Now, let's go ahead and draw this out. We're going to have a minimum of 3 columns because we're using going up this way as rows, and we're looking at the division running around this way as columns. But in any case, it's always, let me distribute that a little bit more evenly, it's always 180 degrees. So I'll give it something that looks like this. This is not drawn to scale and it's not drawn to perfection. But I think that gets the idea across. So if we were to look at this guy from a top view and we were to only have 3 columns, this is how we're going to see it. So the lines I'm drawing right now represent the different rows. And on these rows, you can see, here are our benches. 1 bench per column on each row. I'm not going to draw them all. There's just a few of them, okay? And now we're going to come in behind this with our crowd sitting on top of our benches. And we're going to give quite a bit of control. This space in here needs to be controllable so that if we wanted something really tight, as we see there, or if we want something that has a lot more space, if we want more columns, we want to be able to control, as long as we have a minimum of 3. So here is several. Again, very quick sketch. But an artist is going to be able to go in there and say, all right, number of rows, tick, 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 number of columns, tick, 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 tick. And as they do, they'll get more and more detail around this way, and they'll get more and more detail up in that direction by adjusting columns and rows. All right, so that is what we are looking at creating. Just a very quick overview. Now, we'll spend a little bit of time in the future here talking about the crowd itself, the kind of control that'll be on the crowd, how the shader is going to work, because the shader is going to be a bit more sophisticated than some of the shaders we've seen so far, where we're going to basically within the shader assemble what each of our characters are going to look like, and we need to be able to randomize their eyes, their hair, their skin color, the outfit they're wearing, and by having a handful of eyes, mouths, nose, hair, etc., you can come up with a very random looking audience, which is really cool. All right, Steve, before I start breaking down what we're going to do in this video, is there anything you want to add to this sort of overview?
Oh, I think this pretty much covers it.
Okay, well, let's go ahead and erase part of this out, and then let's talk about what you're going to do. Just want everybody to remember these videos are going to be a lot shorter so that we can stay highly focused. So what we're interested in right now is part of this guy. And when I say part, what I'm referring to is just this and sweeping that around. We're not going to worry about all of the thickness yet that's going to come with it. Okay, actually that's drawn just slightly wrong right there. There we go.
Cool.
We're not going to worry about all of that. That's going to come up in the next video. I just simply want to have this shape that gets swept around into, it won't be nice and round like this. Just keep that in mind. It'll be into our different columns. I want to get that in place. Let's go ahead and get the digital asset created. Let's get a few parameters on the digital asset. Let's go ahead in this video and make it so that we can control the number of rows going up this way and the number of columns that we have going around. And I also want to make it such that we can control this inner radius right here. If we can get all that wrapped up in this video, I'll be happy. So how are we going to do this? Well, let's first, as we've talked about in the past, let's first study what it is that we need to produce. Well, we can see right off the bat that we're going to need some sort of way of having a profile that looks like this. And if we could have a profile that looked like this and revolve it, we could get something like that. It's kind of what we're looking for here. So that is exactly what I want to do. I want to use a curve to create a profile curve that's going to represent each of my rows. And then I need some clever way to be able to make it to where I can extend it however many number of rows I want. And it's going to look like steps. In fact, I might even just call it steps to begin with, but we know we're talking about number of rows. And we'll worry about that first before we even get into the revolving issue. So how do we produce this guy right here? Well, very simple. I need some steps. How can I create some steps? I'm going to create a curve. And with the curve, you guys saw in the pool video that Steve made that curve that ran around the two rails on the top of the pool that allowed us to give a nice beveled edge between the outer and the inner portions of the pool. And he did that by simply dropping down a curve node and then going up and specifying the locations of each point individually to give us, if you recall, this right here. Everybody remember that? So we're going to do the same kind of thing, but now we're interested in something that looks like that. Watch how this works. Let's go ahead and clear all this off real quick. So point, point, point. If we were to look at the numbers of the points, it's going to be 0, 1, and 2. We're not interested in creating a NURBS curve this time around.
Exactly.
Otherwise, we'd end up...
Yeah, so unlike with our pool, we're going to be creating just a polygonal curve, and that's going to give us those nice hard step edges.
Straight, kind of straight lines like such. No. That's a little bit better. Ah, yeah. Look at that.
Fantastic.
Now, again, Steve's going to be specifying numbers, and the numbers are going to look like this. First of all, let's go ahead and establish our directions. Going back in this direction right here is negative Z. This is going to be important because, once again, we're sweeping around. So we're going from negative over into a positive direction. So negative Z, and, of course, going up, we all know that this is going to be a positive Y direction. So if we were to look at the coordinate of each of these points, what we would find is that the first guy would be located at 0, 0, 0. The second guy has moved up only 1 in Y. We have not moved off of Z or X axis, so it is going to be a 0 up in Y to a value of 1, 0. And then finally, with the last guy, we have moved in Z. So this guy, and we're still up in Y, so this guy is going to be 0, still up in Y, so we're at 1, and we have moved back 1 unit in Z, so negative 1. So if he puts these numbers in, starting with 0.0, then 1, and then 0.2, and then hits enter and checks the visibility, we're going to have this curve right here.
And it's worth noting that the specific positions of these points are kind of important because we've built a step that is 1 unit high and 1 unit back, and that's going to come into play in a number of areas through creating this stadium.
Absolutely. Scaling is going to be nice because anytime you scale by 1, you're just going to get your scale, factor that you're putting in. And this very next step, creating our rows, is going to be really handy. So if I was to start drawing out some of this, this all began with the friendly curve node. Once again, I'm not going to be drawing out all of our network as we work through this thing, but I'm going to draw out enough for everybody to get an idea. So now to have multiple rows, here's how I'm going to go about doing this. I'm going to wire this into a copy. And check this out. If I just created this guy right here, and we know that we're working between 0 and 1. So this point right here was minus 1 unit back, right, in Z, and we're 1 unit up in Y. If I was to take this curve and copy it back 1 unit and up 1 unit, wouldn't it start right there? Answer, yes. So we would have this. Okay, so now we would have gone up 1 unit, 2 units. Okay, so if I say make another copy, if I do a transform cumulative, it'll continue. Basically, each guy will inherit the transformations before it. So it's like with that offset. So the next copy would start right here, and we'd have this. And with each copy, it would continue to grow row by row, or step by step in this particular case. So on our copy node, one of the parameters that we have is the number of copies. And Steve will show you that as he plays with this parameter, this is the effect we're going to see. It's just going to go as long as we have transform cumulative checked, and we will. So at this point, we can go ahead and turn all of this into a digital asset. So let's just go ahead and come all the way up here and say this is our asset. Excellent. All right, so with digital asset, we can now go ahead and put in a rows integer parameter, and we can go ahead and lock it to 1. Why lock it to 1? Because we always want, so back to our profile right here, we always want at least 1 row. So here's a case where we have just 1 row with our little trying to mix the word bleacher and bench together, and it's like blencher. It just doesn't work. So there we are with our 1 bench, okay? But we need a minimum of 1 row, because if you can go less than 1 row, which would be 0 since this is an integer type, that means you don't even have a stadium, so what's the point, all right? So we can take that row and we can basically use it to drive. So what we're going to do is number of copies is going to reference this value right here. And then that is going to allow us to control the number of rows that we have. So that's easy enough. Now we have our rows incrementing, looking good, but we have a bit of a problem. If we were to look very close right here, what would we see in regards to our points? Starting with our first copy, you would find its points sitting on top of points from the original object, and each copy afterwards would have its points sitting on top of the previous copy's points. And here's what I mean. We start out with this, point, point, point. Now we copy, we move it over and up, another point, point, point. Another row, another point. So here, and then let me go ahead and just draw this one out real quick. So here we are, 2 points, 2 points. We want to go ahead and take these different primitives. So this curve right here, this is 1 primitive. It's another primitive. It's another primitive. We want to just turn this into one giant primitive. And to do that, all we need to do is simply wire the output of this into a join sock. And that will fuse our points together. All right, excellent. So now we have exactly what we're looking for. We have this shape with however many rows we specify up at the asset in the rows parameter. Now we can, I'll go ahead and put an S up here. That'll make me feel better. Rows. Cool. Now we can go ahead and take the output of the join and put it into a Revolve node. And the Revolve node is going to take this shape right here, and it's going to sweep it around for us, all right, giving us the shell, the top shell of our stadium, if you will. So that's fantastic. There's some things we're going to need to do. First of all, it's going to want to take it and make it a complete tube-like shape. That's going to kind of look like this. There we go. That's going to go all the way around. That's horrible drawing, but I think everybody gets the idea. Since we know that we only want 180 degrees of a sweep, we're going to go ahead and tell the Revolve node that we want it to be an open arc. So now we can go in and control a start and end angle. And we're going to set our end angle to 180 degrees. So I'll just put end, A-N-G, and we'll set that to 180 degrees. And now we end up with this guy right here.
Not quite that guy right there.
Not quite, but you know what I'm getting at. Too much to draw. We're sweeping him around 180 degrees. I'm not even going to worry about drawing that.
Because it looks crazy.
Yes, it does. Now what we're going to do is we're going to go in and we're going to set up our columns. So how can we control the number of columns that we have as we work our way around? Again, from a top view, if we have 1 column, 2 columns, 3 columns. Well, we're going to go back up to the asset level and we're going to add columns. And you're going to have divisions as a parameter down there on the Revolve node. And if we simply take divisions and reference columns up here on the asset, and again it's going to be of integer type, then we have the ability to control how many of these guys we have through the asset, though we are going to lock columns on the asset to a minimum of 3. Because if we were able to go below 3, let's say we had 2, you'd have something like that. And we're not looking for something like that for our stadium. That really wouldn't work too well for us. So that is where we would like to be by the end of this video. Again, this is a top view. Actually, there's one more thing, thinking about it, that we can go ahead and throw in there. The way I keep drawing this with this space in here, but to give a more accurate representation of what it's going to look like, take a look at this. Where did we build our first points at? On 0. So what's really going to happen is this. So basic, a whole bunch of divisions. There we go. Like a cheese wedge that's been swept all the way around and the edges are touching. So you're just going to have this paper thin line right there. We need the ability to stretch this out as I was talking about earlier in the video. Okay? Well, how do we give that ability? Well, if this guy right here and this guy right here were pushed off of 0, the negative direction, the further that they are pushed out, let's say that this is center, right? Let's say we've pushed it all the way back to here. When we revolve around, we're going to revolve around to that distance on this side, as opposed to having the two touching in the center. Just to kind of back up for just a second, as I've been drawing all this, I've been drawing it with the space separation in there, just so that the drawing makes sense as to what we're doing. But how do we achieve this right here? It's very easy. It's simply moving this primitive back. We take this curve, we move it back. How can we do that? Well, let's just go back to before we copy, and let's run this guy into a transform node.
And just talking about the drawings looking weird, that's what I was referring to earlier when I was like, it's not going to quite look like that because of the fact that, in actual fact, that first row is going to be all up on the origin, but that would have made the drawings look very confusing.
Yeah, I knew exactly what you were talking about. That's why I was like, I'm not even going to draw that because I'd have to end up explaining that. So now here we're just going to correct that.
Sweet.
So what we're going to do is let's just call it an XFRM. Here's a transform node, and like I said, if we just move this guy backwards, meaning in the negative Z, if we just continue pushing it back in the negative Z, that is going to give us the space we need. So here we are moving off of the center to give us this gap. So we'll come back to our asset and we'll create an inner radius. And then we'll have inner radius basically drive our transform Z. So if transform Z referenced a negative inner radius, then as the inner radius goes up, that number goes up, it means go back further negatively in Z, and that's going to give us the spacing that we want. So negative CH, and we'll just put some quotes in there and reference our inner radius. So inner radius. And our quotes off, and there you go. So now we are referencing this guy, and we are causing our curve to get pushed back this way, which takes this guy right here and turns him into something that looks more like this. Boy, look at that nice drawing, huh? Yeah, that's awful.
That's pretty good.
There we go. So now we're controlling the spacing right here. So I'd like to get all of this accomplished in this video, which should only take Steve about 5 minutes. There's not much going on. I just kind of want everybody to see what it is that we're doing in order to get this. All right, so let's jump over into Houdini real quick.
All right, so let's jump over into Houdini. And I'm going to begin by creating a new geometry node object level that we can put our asset inside. So I'm going to drop down a geometry node and enter, and let's rename this guy to bleachers. I'm going to push enter to jump down inside and delete out the file. And let's start by creating that curve that's going to become just a single step in our rows.
Okay.
So I'm going to push tab, and I'm going to create a curve. Enter and enter to create that, and I'm going to rename this to profile curve.
Again, this is just like the curve Steve created back on the pool.
Exactly, and it has 3 CVs. We've seen these over in Photoshop. 0, 0, 0, 0, 1, 0.
Wait, we gotta give you an arrow.
Fantastic.
All
So
right.
0, 0, 0, 0, 1, 0, and 0, 1, negative 1.
And we're just gonna enter those with spaces between the groups of numbers.
Exactly, so 0, 0, 0, space, 0, 1, 0, space, 0, 1, negative 1, and enter. And if we home up with space H on our curve, bring up points and point numbers, we can see the curve in positive Y and in negative Z.
Pull up a side view real quick.
Yeah. So space 4 to pull up a side view, and there we go.
Very nice.
Space 1 to go.
You don't like the side view?
Perspective. We can stay in the side view if you really want
to.
to.
It keeps everything nice and straight.
Space 4, and now we're in a side view.
Very good. All right.
Cool. So we've got a single curve. Let's copy this guy to get multiple curves. So I'm going to right click on the output of our curve and wire him into a copy sop. And I'm going to rename this copy to copy for rows. Bring our visibility down here. And we've seen if we were to translate, well, I'm going to set our copies to 2 so we can see the effect this has as we actually set our transformations.
Which right now we do have 2 copies, and you can see all of the point numbers on top of one another. So they're right on top because we've done no transformations yet.
But if we were to translate up in Y by 1 for every copy that we have, we can see, and if we start increasing this, fantastic. And then we want to translate by negative 1, so we move back in Z by 1 for every copy.
And again, you'll note that transform cumulative is checked, and that is why we have this offsetting effect with each of our copies.
Exactly. So as we start increasing our number of copies, we get those steps. So now we actually have enough to now create the parameters that are going to control this guy. And to do that, we need to create the asset first, so we have a place to put those parameters.
Exactly.
So I'm going to select both of these nodes. I'm going to push Shift-C to collapse down into a subnet. Double-click to rename, and I'm going to rename this to bleachers. I'm going to right-click and come down to Create Digital Asset. I'm going to name this guy bleachers with a label of bleachers with a capital B. We don't need any inputs for the same reasons as all our other assets. I'm going to create an OTL file for this guy. So I'm going to browse to our HIP file. Our HIP file is saved within our project folder. I'm going to jump up one, and then I'm going to find our OTLs folder. And I'm going to save this as bleachers.otl and accept. And again, just installing to the current HIP file. So this will bring up our type properties window. I'm on the parameters tab, so we can start creating parameters. I'm going to create a folder to begin with. And I'm going to name this folder to, let's name it to bleachers. And inside this folder, I'm going to create 2 integer parameters, one for our number of rows and one for our number of columns. So let's drag a integer into our bleachers folder and another integer into our bleachers folder. This guy is going to be rows, and I'll give him the label number of rows, and we want to lock him with a minimum of 1. And our second guy is going to be columns. I'll give him the label number of columns, and we want to lock him with a minimum of 3.
And again, a reminder, we need to have at least 1 row. Without at least 1 row, you'd have nothing to put our benches or characters on. And we want at least 3 columns because we don't want a V-shaped or worse, a line.
Just a straight line.
Yeah, that'd just be a mess. So once again, a minimum of 3 for our columns.
Fantastic. So I'm going to accept out this window. Jump back to Houdini. So we've got our asset with our 2 parameters. I'm going to enter to jump inside our asset, and we can now control our number of copies with that row parameter we've created. So I'm going to enter our number of copies parameter on our copy SOP. I'm going to enter ch, jump up and grab our rows parameter that's up on our asset. And if I right click on our asset and bring up our parameters, as we start increasing our rows, we're creating our various steps.
Now you can point out the point numbers that are on top of one another at each of the starts. Yeah.
So if we zoom in, we have point 0, point 1, point 2. We can see there's another point over there. We know this is point 3 because then we go to point 4. We have point 5 and point 6 here, then point 7 and so on. So we've actually got 2 points on each of these corners. So let's resolve that now, and we can do that by wiring this into a join SOP. So I'm going to right click on the output of the copy. I'm going to type join, enter to accept that, enter to create the join SOP. If we bring our visibility down, you'll see we now go 0, 1, 2, 3, 4 and so on. So we only have 1 point at each of these corners. You also notice if I middle click on our copy for rows, we had 4 primitives, 1 for each step. Middle click on our join, we now only have 1 primitive for the entire guy.
Very nice.
So now that we've got this guy joined together, we can go ahead and get him revolved. So I'm going to right click on the output of the join, and I'm going to wire him into a revolve SOP. Enter to accept that, enter to place him into the view, bring my visibility down, and I'm also going to push space 1 to come over to a perspective view. Firstly, you can see what we were saying about the very first row being all centered up on the origin and how hard that would be to draw on the whiteboard.
Right.
So let's get this guy so that he's going through 180 degrees and set him so that he has the number of columns that we specified, and then we'll go ahead and fix up that inner radius.
Okay.
Fantastic. So on the detail tab of our Revolve SOP, we have the ability to choose our Revolve type. Currently it's closed, which means we're going to go through a complete 360 degrees. Let's set this to an open arc, where we have now control over our start and, more importantly, our end angle. And we can bring this end angle back so that we have 180 degrees, and that will give us our half circle that we were looking for. Now I'm going to push W to come into a wireframe view, and we can see we have a number of divisions going around that half circle. That's controlled by the divisions parameter. And if we control this parameter directly by our number of columns, we'll see we could have 3 columns, 5 columns, and so on. So I'm going to grab our divisions parameter and set him equal to the columns parameter that we created up on our asset. And if I right click on our bleachers and come down to parameters, you can now see as we increase our columns, we increase the number of divisions on our Revolve SOP.
Very nice. Only one thing left to do in this video.
Exactly, and that's to create the inner radius. So I'm going to create the parameter for him first, and then we'll wire that transform SOP up at the top of our network.
Okay.
So I'm going to right click on our asset and come down to type properties, that is off the bottom of the capture region. And I'm going to create a float parameter that I'm going to name inner radius with the label inner radius, and I will lock this with a minimum of 0.001. And if we accept this, I'm now going to come up to where we first create that profile curve. And if we were to translate this single curve back in Z, well then, since the copies are all being relative to the original copy, are moving up in 1 and back in Z 1 each time, they'll all be offset by that translation. And if they're offset by that translation, the revolve will still revolve around the y-axis, but it will be offset, so we're going to get that gap.
Exactly.
So I'm going to right click on the output of our profile curve, and I'm going to wire into a new transform SOP, enter to place that in our network, and I'll rename this guy to something like inner radius underscore xform. And we can see if we translate back in negative Z, as we start translating back, we open up the inner, because we take our profile curve, we translate him back. That has the effect of translating all of our copies back, which then space out our revolve. And the amount we're going to translate back on our translate Z is going to be the negative of that inner radius parameter we just created on our asset. So now if we right click on our bleachers asset, come down to parameters and start increasing this guy, we're going to boost out the inner radius.
Very nice.
And with that, that's actually everything that I want to show in this video.
All right. Well, with that, that is going to wrap this one up. Thanks a lot.